Picture yourself falling through 29 kilometers of pure frozen ice on Europa, Jupiter's icy moon. No light, no sound, just the crushing pressure of a frozen world surrounding you from all sides. And then after what feels like a lifetime of darkness, the ice finally breaks. You burst through into open water. But this is not any ocean you have ever known. There is no sky above you, no surface to swim toward. Just a ceiling of ice stretching in every direction, sealing you inside a body of water that has never seen a single ray of sunlight. And the terrifying part is not the darkness. It is the growing suspicion that you might not be alone. Europa does not seem dangerous at all, from far away. It looks almost calm, a pale frozen ball marked with reddish-brown streaks, like veins running just under frozen skin. It is slightly smaller than our own moon, just about 300 kilometers wide. It circles Jupiter once every 3.5 days, locked in a gravitational grip so strong that the same side always faces the gas giant. On the surface, it is among the smoothest objects in the entire solar system. Barely any craters, no mountains. Just ice, cracked and scarred, but strangely flat. And that smoothness is the first clue that something strange is happening beneath. On most moons and planets, craters pile up over billions of years. Europa barely has any. That means the surface is being constantly replaced. Something from below is pushing upward, erasing the old scars and laying down fresh ice. The most widely accepted explanation is simple and unsettling. Europa has an ocean, a global liquid saltwater ocean, hidden beneath kilometers of frozen crust, and it has been churning quietly in the dark for possibly billions of years. The first real clues came from NASA's Galileo spacecraft, which circled Jupiter from 1995 to 2003. During its 11 close passes of Europa, Galileo's magnetometer picked up an induced magnetic field, not coming from the core, but from something electrically conductive hiding beneath the surface. The only explanation that made sense was salty liquid water. Then came the images. The cracks on Europa's surface form massive intersecting patterns called lineae, some stretching hundreds of kilometers, consistent with the surface flexing and splitting apart over a liquid layer. Some regions showed chaos terrain, areas where the ice appears to have broken apart, shifted, and refrozen in a completely different arrangement, like a jigsaw puzzle that was shaken and put back together wrong. That kind of disruption only makes sense if something warm and fluid was pushing up from below. But how is liquid water even possible this far from the sun, at around 670 million km away? The surface temperature sits at around 160 degrees Celsius. Everything should be completely frozen, and it would be if Jupiter was not there. Europa is caught in a gravitational tug of war between Jupiter and its neighboring moons, Io and Ganymede. Their combined influence keeps Europa's orbit slightly elliptical, and that changing distance creates tidal forces. Jupiter's gravity physically stretches and compresses Europa's interior with every orbit. That constant squeezing and stretching generates heat through a process called tidal heating. Think of it like bending a paperclip back and forth. The metal warms up right where it bends. Now imagine that same thing happening on a planetary scale, non-stop, for 4.5 billion years. The ocean is enormous. Current estimates suggest it could be around 100 kilometers deep. The deepest point in Earth's oceans reaches about 11 kilometers. Europa's ocean could hold 2 to 3 times the volume of all water on Earth, and all of it is locked away in complete darkness beneath a frozen lid. In January 2025, NASA published results from the Juno spacecraft's 2022 flyby. Using its microwave radiometer, Juno measured the temperature profile of Europa's ice and settled a debate that had raged for decades. The ice shell averages about 29 kilometers thick. That is roughly 18 miles of solid, rigid, frozen water between the surface and the ocean. Juno confirmed the thick ice model, and that comes with a serious implication. A thick ice shell means the ocean is completely cut off from the outside. Europa's surface is constantly bombarded by Jupiter's radiation, which breaks apart water molecules and creates reactive chemicals. If those chemicals could make their way through the ice and reach the ocean, they could potentially support life. But 29 kilometers is an incredibly difficult barrier to cross. Juno detected small cracks and pores in the near surface, but they only extended a few hundred meters down, nowhere close to reaching the ocean. And yet, there are signs that the ocean is not completely cut off. In 2012, the Hubble Space Telescope captured images of what appeared to be enormous plumes of water vapor erupting from Europa's South Pole region, rising as high as 200 kilometers above the surface. Then in 2018, scientists went back to old Galileo data and discovered something extraordinary. During a 1997 flyby that brought the spacecraft within 206 kilometers of the surface, the magnetometer recorded a jump of more than 200 nanoteslas in just 3 minutes. At the same time, the plasma wave spectrometer caught a sudden spike in plasma density. The only explanation that fit was that Galileo had flown straight through a water vapor plume. The proof had been buried in the data for over 20 years. If those plumes are real, the ocean is actively venting its contents into space. Europa is not just frozen, it is breathing. And that means a spacecraft could fly through one of those plumes and sample the ocean directly. No drilling through kilometers of ice, no landing on a surface that would destroy most electronics within hours. Just a flyby through a cloud of ocean spray. And that brings us to the radiation. Europa sits deep within Jupiter's magnetosphere. At the surface, the radiation level reaches around 4 sieverts per day. Just 1 sievert is enough to cause radiation sickness. 5 in a single day would kill you. The radiation also destroys any organic material on the surface. If biosignatures were brought up by geological activity, Jupiter's charged particles would shred them. In the highest radiation zones near the equator, you would need to dig 10 to 20 cm below the surface to find material that has not been chemically altered. So, could anything actually survive in that ocean? We honestly do not know, but the conditions are unsettlingly promising. Life needs liquid water, chemical energy, and the right elements. Europa has the water, possibly even more than Earth. It most likely has the elements too. The only real question mark is the energy. On Earth, life thrives in places that resemble what we imagine Europa's ocean floor to be. Along mid-ocean ridges, hydrothermal vents pump superheated mineral-rich water into the freezing darkness. Entire ecosystems live there, completely independent of sunlight. Bacteria feed on chemical energy, converting hydrogen sulfide into food. Those bacteria support worms, crabs, shrimp, and fish, life that has never seen the sun. But in 2024, studies suggested that Europa's rocky interior may not produce enough heat to drive volcanic activity on the seafloor. Simulations showed that magma likely cannot travel through the thick rock above it to reach the ocean floor. Without active volcanoes, a major source of chemical energy disappears. There is another side to this argument, though. A process called serpentinization is capable of producing chemical energy at much lower temperatures. When seawater slowly seeps into cracks in rock and reacts with certain minerals, it releases hydrogen gas and heat. A 2016 NASA study found that Europa's ocean could maintain an Earth-like chemical balance through serpentinization alone. And simulations from 2024 showed that low-temperature hydrothermal systems on ocean moons could persist for billions of years, long enough for life to emerge. The James Webb Space Telescope confirmed the presence of carbon dioxide on Europa's surface in 2023, specifically in Terra Regio, a region of chaos terrain. The carbon dioxide seemed to be coming from deep inside, suggesting that the ocean itself holds carbon compounds. Webb also confirmed the water vapor plumes. Europa was not just leaking, it was actively pushing out the contents of its hidden ocean. On October 14, 2024, NASA sent Europa Clipper into space aboard a SpaceX Falcon Heavy rocket. It carries 9 scientific instruments built to map Europa's surface, measure its ice shell, search for organic molecules, and verify the subsurface ocean. The spacecraft will reach Jupiter in April 2030 and carry out 49 close flybys, coming as close as 25 km from the surface. If the plumes are active, Clipper's mass spectrometers could sample them directly, tasting the ocean without ever touching the ice. The answer, whatever it turns out to be, is unsettling either way. If Europa's ocean is empty, it tells us something deeply uncomfortable about just how rare life might be. But if something is alive down there, even a single-celled organism surviving on chemical energy in complete darkness, it changes absolutely everything. It means life is not just a lucky accident. And if it emerged twice in one solar system, then the universe is far from empty. Europa does not care about our questions. It just keeps orbiting, keeps flexing, keeps hiding its ocean beneath 29 kilometers of ancient ice. Whatever is down there has been waiting in the dark for longer than complex life has existed on Earth. And right now, a spacecraft is hurtling toward it, carrying the instruments that might finally let us listen. Thanks for watching, and I'll see you in the next one.